Hello, everybody. The topic of today's discussion is antiderivatives and the indefinite integral. And the idea of an antiderivative should actually be something that makes some sense in regard to the question that I'm going to ask right here, which is this. We ask what function will result in x squared as its derivative? Now, a moment's thought of this is, well, if I had an x cubed function, that might do it, wouldn't it, right? Well, let's take it. Let's take the derivative of x cubed, but we would note that when we do that, we actually end up with 3 times x squared as its derivative. But there's no 3 here. So a moment's reflection is, well, if we took 1/3, perhaps, would that do it? Well, a derivative with respect to x of something like 1/3 of x cubed would certainly result in a derivative of x squared, because we'd be taking 1/3 of 3x squared, and sure enough, that would be our derivative. So we would say, well, the function that would have to result right here would be one like this. F of x would have to be equal to 1/3 times x cubed. Now, we say that could be a function. There might be more, right? If you think about it, y could equal something like 1/3 of x cubed, well, plus 1, right? Or minus 100, or something else like that, right? But we'll notice that this constant goes to 0 when we take its derivative, so we don't really know for sure what function it is, but we know that the function must contain 1/3 of x cubed in it to get x squared its derivative. Now, if we ask a similar question about x third, a moment's reflection like the one above would reveal that, well, maybe we should be taking the derivative of a function like 1/4 times x to the 4th, because that derivative would result in 1/4 of 4x cubed, and sure enough, we would get x cubed as the derivative. So y equals a function containing 1/4 x to the 4th plus some constant, right? It could be any constant. We're not really sure. But in any case, that's the point. What we're doing is we're reversing the process of taking a derivative when we think about what an antiderivative means. And formally, we can say that a function f, some function f, is an antiderivative of some other function, small case f in this case, on an interval I when f prime of x is equal to f of x for all x in some interval I. And essentially what we've been doing is we've been solving what we would call a differential equation. That is, we're being told what the derivative is, and the goal is to find the original function y from which that function came. And we can see, well, if dy dx is equal to x to the 4th, and using the same pattern we discovered above, we might say, well, that would mean that y would have to equal something like 1/5 times x to the 5th plus some constant. And we call this solution right here, where we don't know what the constant is, but we know that c is some constant, that this function, whatever it is, would have a derivative of dy dx equals x to the 4th. That constant, we're going to call that the constant of integration. And what we're really doing right here is it gives us a way to represent all antiderivatives, or a family of antiderivatives, whose derivative would be what we say our differential equation should give us an answer to. And we call that a general antiderivative. So the general antiderivative is the expression y equals, in this example, 1/5 x to the 5th plus that constant of integration. And that's a general solution of a differential equation. Now, we do have a more formal proof that tells us if f is an antiderivative and g is an antiderivative of f on the interval also, right? So we've got two different functions. Then g of x and f of x will only differ by that constant. And that's what we're saying right here, right? Because we could take any constant and say, well, if the function is constant, if the derivative constant was equal to 0, that would work, but it would also work if y was equal to 1/5 x to the 5th plus 100. And the only difference between these two functions, which we'll call f of x, and we'll call the second one g of x, the only difference between g of x and f of x is that constant of 100. So by this representation, the only difference would be just whatever that constant is. So we want to make sure that we understand what that constant of integration represents.